Good day everyone. Welcome to another video lesson discussion, Understanding Freefall. Here are today's goals. First, we will define what freefall is. Next, we will describe the characteristics of freefall. Third, we will apply the kinematic equations to solve problems involving freefall. By definition, freefall is the motion of an object under the influence of gravity alone, without any resistance from air or any other forces. It means in freefall, the only force acting on the object is gravitational force, and this gravitational force causes the object to accelerate as it falls. And that acceleration caused by the gravitational force is represented by g, small letter g, also known as the acceleration due to gravity. And this has a constant value of 9.8 meters per second squared. Or since this acceleration is directed downward, therefore we make use of negative 9.8 meters per second squared. The negative sign only denotes direction. For simplicity, we will use g equals negative 10 meters per second squared. What does g equals 10 meters per second squared mean? In simple terms, the acceleration due to gravity equals to 10 meters per second squared means that when an object falls, its speed increases by 10 meters per second every second. If you drop an apple from a certain height, after a second, its speed will be about 10 meters per second. 2 seconds after, the speed is 20 meters per second. After 3 seconds, its speed will be 30 meters per second, and so on. Thus, Earth's gravity is pulling the object downward at a constant rate of 10 meters per second every second, making it fall faster as time goes on. However, in the absence of air resistance, such condition is called a vacuum. All objects, regardless of mass, whether light or heavy, they will fall at the same rate. If we are going to compare a feather and a hammer when dropped in a vacuum, meaning there is an absence of air resistance, both bodies, the feather and the hammer, will hit the ground at the same time. On Earth, air resistance affects lighter objects more than heavier ones, causing them to fall slower. A feather falls slower than a hammer due to the greater air resistance encountered by the feather or the lighter body. But if air resistance is removed, such as in a vacuum, both bodies would fall at the same rate. Thus, they reach the ground at the same time. To further validate this, you can actually do this on your own. So you will drop this paper and a coin at the same height. At first, of course, after releasing both bodies, the paper will reach the ground slower. That is due to the fact that air friction hampers the motion or the rate of fall of the paper. If we are going to remove that air friction, it's impossible for us to do that in the classroom, but we can minimize air friction by simply crumpling the paper, forming a ball. air friction is now minimized, both bodies will reach the ground at the same time. You can comment on this, validate whether you have come up with the same result as this explanation. Now moving on, what are the equations involving free fall? Now since free fall involves constant acceleration due to gravity, the equations are then derived from uniformly accelerated motion, or the UAM. When using g for the acceleration due to gravity, since it's acted downward, the equations will become from UAM to free fall. So changing the A to acceleration due to gravity, which is constant, will become Vf equals Vi minus Gt. And it is now having a negative sign because it's acted downward. Second equation, Vf squared equals Vi squared plus 2Ad. So from this, change the A to G will become Vf squared equals Vi squared minus 2Gt. Next, D equals Vit plus 1/2 At squared. So, under free fall, it becomes D equals Vit minus 1/2 Gt squared. So let's have this sample problem using free fall equations. A ball is dropped from rest from a height of 40 meters. How long does it take to reach the ground? And B, how fast is the ball just before it reaches the ground? So in this case, we are asked to solve for the time it takes to reach the ground. Secondly, we are also going to determine how fast, or the final velocity of the ball just before it reaches the ground. Now, to be able to solve this problem efficiently, it's important that we can visualize the problem and we can determine the given. So I have here the ball from a certain height, and since it's dropped from rest, that means the initial velocity is 0. Next, that height is equal to 40 meters. So, and since we are using the top as our reference, so I mean that top portion going down will make use of negative sign for our distance or the height. So we are using negative 40 meters. And as we all know, the value of acceleration due to gravity, or the rate of fall of the object, is negative 10 meters per second squared. That's the constant acceleration. So here are the unknown following the group sum method given. Then the unknown A is time. Time is asked. B, the final velocity. Next, what's the formula solving for time? Now, in choosing the right formula, we have to consider both the given and the unknown should be present in the formula for us to determine the correct equations to be used. These four quantities must be present in our formula. So, following this, the formula to be used then is D equals Vit minus 1/2 Gt squared. And since we're looking for time, so we need to transform this formula to specifically solve for time. So since Vi is 0, that means then that we can cancel the Vit, so that it is now equal to D equals negative 1/2 Gt squared. Next, from there, that 1 half gt squared can also be written as negative gt squared over 2. Since we're looking for time, we need to cross multiply d and 2 together with gt squared on the other side. So by applying this, we now have gt squared equals 2d. And since we're looking for time alone, we have to get rid of g. So with this, we divide both sides by g. So g cancels out. That makes the equation t squared equals 2d over g. So that means square root of t squared equals the square root of 2d over g. So finally, we now have the equation for time as t equals 2d over g. So that is our right formula for time. Next, after the formula, next is to prepare for the solution. Using this equation or the formula, we can now substitute the given variables with actual numbers. So from the formula t equals square root of 2d over g, that means t equals square root of 2 times negative 40 over negative 10. And our time now is equal to 2.83 seconds. So that means 2 times negative 40, that's negative 80. Negative 80 divided by negative 10. So that is equal to positive 8. Square root of 8. Now we have an answer equivalent to 2.83 seconds. And we are able to solve for our time. So next is solving for the VF. So the right formula to use is VF equals VI minus GT. So VI is there, G, and since time is already solved earlier, so we make use of the value for time for us to know the value of VF. So this is already our equation solving for the final velocity. So using the equation and knowing that VI is equals to 0, therefore VF then is equal to negative GT. And thus, substituting this with actual values, g for negative 10 or negative g is negative 10 and time is 2.83, that's the one we just solved earlier. So the final velocity now is negative 28.3 and the correct unit, of course, final velocity is negative 28.3 meters per second. So take note that the negative sign only indicates direction. That final velocity is directed downward. So you can also answer it 28.3 meters per second downward or negative 28.3 meters per second. Now it's your turn. You and your friends are having a party at the Skyview Lounge of the Crown Regency Tower. While taking a group selfie, your latest iPhone 16 model accidentally slips from your hand and falls freely to the ground below. You all watch in shock as it disappears from your sight. If the phone takes 5.3 seconds to hit the ground, determine the following. A. The height of the Skyview Lounge from which the phone was dropped, meaning that distance is equal to the height. And B, what is the final velocity of the iPhone just before it crashes to the ground? Always remember, King Juan Learning, embrace learning, keep going. Thank you very much.